Welcome to this explainer. Today, we're diving into a massive, fundamental shockwave that is actively rewiring Silicon Valley right now. And surprise, it actually has nothing to do with spending billions more on massive data centers. It has everything to do with highly capable, shockingly cheap open-source models out of China, bringing costs absolutely crashing down. We are at a really fascinating inflection point. For the last couple of years, the whole narrative has been entirely dominated by these massive American labs building incredibly expensive, colossal AI models. But as we're about to see, that reality is rapidly changing.
There is a really stark transition happening in the market right now. In the old era, which, let's be honest, in AI time is basically just last year, everyone was completely obsessed with chasing abstract leaderboards. It was this intense race to see who had the smartest model, who was the absolute best at coding, who crushed the complex reasoning benchmarks. But enterprise leaders have quickly realized that is just not how companies actually buy software. In this new era, the definitive make-or-break metric is intelligence per dollar.
So here's our roadmap for today. First, we'll cover the intelligence per dollar era. Second, China's open-source disruptor. Third, the barbell AI strategy. Fourth, geopolitics and sovereign AI. And finally, the hardware supercycle.
All right, let's jump right into Section 1, the intelligence per dollar era, and see how this is building a completely new financial reality for businesses.
Think about it from the perspective of a Fortune 500 CEO. You have thousands of employees, right? If each of those employees uses an AI model a dozen times a day to, say, plan a project, write some code, or review a contract, you are generating an absolute explosion of tokens, which is basically the basic unit of AI processing. Running those tasks millions and millions of times on the most premium frontier models is completely financially unsustainable. It eats right through the corporate budget. So the conversation in the boardroom has shifted from, hey, what's the smartest tool available, to what is the most cost-effective tool that is just good enough to do this specific job perfectly.
Which brings us nicely to Section 2, China's open-source disruptor.
When Z.AI released their GLM5.2 model out of China, it landed with a massive bang. Developers have been absolutely piling into it because, on highly complex agentic workflows, it is essentially matching Anthropic's incredibly powerful Opus 4.8 model. In fact, on complex benchmarks, this open-source model is just 1 percentage point away from the horsepower of the American frontier. 1%. We're talking about an open-source lag of merely 3 to 6 months. That is barely enough time to update your smartphone software, let alone build a trillion-dollar corporate moat.
But here is the real shockwave. It achieves that near-frontier performance for a mere fraction of the price. Specifically, it costs about 1/5 to run. Now, if you are an enterprise sitting on a massive, heavy data processing workload, the temptation to switch to a model that gives you 99% of the performance for literally 20% of the price, that's impossible to ignore. It places these open-source tools squarely in the ultimate sweet spot of enterprise software: super high performance and incredibly low cost.
So, how are they doing this? Well, a major reason Chinese labs are pushing this intelligence per dollar metric so aggressively is through a fascinating technique known as distillation. It's a bit of inside baseball, but it's a total game changer for the field. Instead of spending billions on massive data centers to train a new model from absolute scratch, you take an incredibly powerful, really expensive model and you use its high-quality outputs to basically teach a smaller, vastly cheaper model how to behave. It's highly efficient, and it is rapidly accelerating the speed at which the open-source community is catching up to the closed proprietary systems.
Moving on to Section 3, the barbell AI strategy. Let's see how business leaders are actually adapting to this.
Enterprise leaders, like Box's Aaron Levy, are completely restructuring their software budgets. Instead of just buying one single model for everything, companies are adopting this barbell routing strategy. Think about your own daily tasks. You wouldn't pay a senior executive to sit there and format spreadsheets, right? Similarly, companies are spending heavily on frontier models for the highly complex orchestration and review tasks, but they push all the heavy lifting, like combing through huge repositories, redlining hundreds of standard contracts, bulk document processing, over to the cheap open-source models. Your actual spending might be split 50-50, but your sheer token volume will be heavily weighted toward those cheap open models.
We are also seeing a major evolution in how we interact with these systems. AI is fundamentally shifting from a personal tool into an embedded coworker agent that actually shares context right across your entire team. We're moving out of this single-player mode where you just ask a chatbot a quick question to help your own personal productivity, and we're entering multiplayer mode. Tools like Claude Tag act as a shared entity inside a company's workspace, say right inside a sales team's Slack channel. It has access to your company's proprietary data in Box, your customer data in Salesforce, and it literally collaborates with the group like a dedicated full-time employee. Because these embedded agents require a massive explosion in token volume to perform that mission-critical work, relying solely on expensive frontier models is, again, financially impossible. Agentic work isn't just answering a single prompt. Agents plan, they write code, they test it, they hit an error, they loop back, and they fix it. This continuous autonomous looping consumes astronomical amounts of compute. And on top of that, as these agents do more economically valuable work, companies really want to fine-tune them on highly sensitive internal data, like M&A documents, which they absolutely do not want to send back out to a public frontier lab.
Which brings us to Section 4, Geopolitics and Sovereign AI.
When governments use blunt instruments like export controls to block access to frontier models, it inadvertently forces a massive reaction. It forces countries and enterprises around the world to urgently build their own redundant, sovereign AI networks. We actually saw this recently when access to powerful models was restricted in certain global regions. For nation-states and massive corporations, this was a huge wake-up call. If your entire business continuity relies on a single proprietary model from another country, and your access to that model can literally be severed overnight, that is a completely unacceptable risk. So what do? They turn to open-source models that they can physically download, deeply control, and run locally as a crucial fail-safe fallback mechanism.
So, all this brings up an absolutely crucial question. If the future of AI software is getting incredibly cheap and open, does that spell disaster for the massive profits of hardware manufacturers? If everyone is turning to these lean, highly efficient models, won't the massive demand for computing hardware just dry up entirely?
Let's look at Section 5, the hardware supercycle, and ask semiconductor expert Stacy Raskin to help us figure this out.
The answer to that question actually lies in a classic economic principle called Jevons paradox. It's super interesting. Basically, by making intelligence cheaper per token, developers are able to invent thousands of brand new use cases that simply weren't financially viable before. So the cost per unit goes down, sure, but the sheer volume of usage skyrockets so aggressively that the total overall demand for the underlying resource, in this case, raw computing power, actually goes up. It goes way up.
Because of this, we are currently witnessing a true demand-driven hardware supercycle, where the thirst for compute is completely overpowering the wildest forecasts across the entire supply chain. And this isn't just a brief passing spike, it is a structural supercycle. We are seeing completely unprecedented 10-gigawatt power and hardware deals just for a single company like OpenAI. The bottlenecks are rolling across the entire industry. First it was the AI accelerators, then it was high bandwidth memory, then networking, and then power components. And because there's finally a massive proven financial return on all these infrastructure investments, we're even seeing a major resurgence in highly funded hardware startups stepping in to build specialized custom silicon.
The speed of development here is just breathtaking. For instance, Broadcom partnered with OpenAI to build a custom chip codenamed Jalapeno. Going from scratch to an advanced hardware chip in just 9 months is an absolute blink of an eye in semiconductor manufacturing. And the end goal there is to drive the cost of inference down by an estimated 50%. This constant, rapid innovation at the hardware layer ensures that no matter what software is running on top, the physical engines underneath keep getting faster and vastly more efficient.
So as long as the AI gold rush continues to scale, the hardware layer is going to thrive, completely regardless of whether the prevailing models end up being closed or open source. Whether a company is running an incredibly expensive proprietary model to orchestrate a huge project, or a dirt-cheap open-source model to parse through millions of old PDF documents, they still fundamentally need the underlying compute to do it. The chip makers are totally agnostic to the software wars. They simply supply the raw horsepower that makes this entire ecosystem function.
To wrap up our explainer today, we really have to ask ourselves a tough question. As open source continues to wildly drive down costs and nations rush to build their own sovereign AI walled gardens, will the very technology that connects us ultimately divide the global ecosystem? We are moving so fast into a world where intelligence is becoming cheap, ubiquitous, and embedded directly into our daily workflows. But as different regions lock down their proprietary data and rely on localized open-source redundancies to protect their borders, we might honestly be looking at a highly fragmented future. It is an incredibly turbulent time of disruption. Thank you so much for joining me for this explainer, and keep questioning these fascinating shifts as they unfold.